are going to move on in this chapter, and we are going to talk about similar polygons. Now, we talked about dilations, and there's a pretty good similarity between the two. A dilation actually takes one particular shape and makes it bigger or smaller, right? Kind of like when your eyes dilate, they get bigger and smaller, right? Or you go to the copy machine and you make something bigger, you zoom it in or zoom it out, make it bigger or smaller, okay? That's a dilation where you take a shape and make it bigger or smaller. Similar polygons is comparing two different shapes, okay? But they're similar if they have the same properties basically as the dilation, okay? It is a composition of one or more rigid motions and a dilation, okay? So what happens, like in this particular example, we have PQRS, okay? And they took and they reflected it, okay? And then they translated it and made it bigger. Yes. I believe that's what they did. Yes, that's what they did. So they took, they reflected it, they translated it, and then they made it larger, okay? And so if you compare PQRS with, let's see, make it bigger. So yeah, JKGH, I believe. Yeah. Then they are similar. Now, one thing that you'll notice, and you can look at this black one and this red one, is that the corresponding angles, just like in a dilation, are congruent. And the corresponding sides are going to be proportional. Okay? So that is what happens when you compare similar triangles. This symbol right here is what we use to state that two figures are similar. Remember, we have a congruent symbol. It looks like this, right? That means that whatever this shape is exactly the same as what this shape is, okay? But if they just use the squiggle like this, okay, then that means this shape is an enlarged or shrunken version of the other one. They're similar to each other, okay? And in similar polygons, the corresponding angles are the same, but the corresponding side lengths are proportional. So that means if you were to compare each one of the sides, they would have the same scale factor or the same ratio, okay? All right, so again, this is the symbol that I use for similar. And here's a pair of similar figures, okay? Notice here that A and E are the same, B and F, C and G, and D and H because of the congruence markings, okay? So the corresponding angles are equal, okay? Now, if I were to look at the side lengths, and when you marry up the side lengths, you have to make sure you marry up the right ones. So, like AB and EF go together because it's in between the 1 and the 2 arc, okay? So if I did 5 is to 2.5, and then I would marry up 6 and 3 because they're between the 2 and the 3 arcs, 6 and 3, and then 8 and 4 would go together, and 10 and 5, okay? And if I were to divide each of these out or reduce them, would they be the same? 5 divided by 2.5 is 2. 6 divided by 3 is 2. 8 divided by 4 is 2. And 10 divided by 5 is 2, right? So the sides are proportional and the corresponding angles are equal. That makes them similar, okay? That's what it means to be similar, okay? All right. How do we write similar figures, okay? It's a lot like congruent figures, okay? Except we use a similarity symbol. And the corresponding order is important. So like if I write A, B, C, D is similar to E, F, G, H, my A and my E are congruent. They're going to have the same measure, okay? I know that just by looking at the similarity statement. My B and my F are going to have the same measure, okay? My C and my G are going to have the same measure, and my D and my H are going to have the same measure, okay? And I can get all of that from the similarity statement, okay? So if I knew that angle A was 50 degrees, what do I know about E? It's 50 degrees, okay? All right? So that's what your similarity statement says. Now, you can also get your proportional sides from your similarity statement, okay? Because the order is important. So like AB is the first 2 letters, it would marry up with EF, which is the first 2 letters. So AB is to EF, okay? Then BC and FG come next, BCFG. then CDGH, CD is to GH, and then DA is to HE, okay? So I can get all of that from my similarity statement too, and if I write it correctly, then these all would have the same ratio also, or the same scale factor, okay? All right. Okay. Determine whether each pair of figures is similar. If so, write a similarity statement. If not, explain why. Okay, so the first thing I always check is the angles. Because if I can rule the angles out, I don't even have to check the sides. Because the side is what takes a little bit of time. Okay, so I notice these both have a right angle. This one's 30. What's this going to have to be? Angle B. It's going to have to be 60 because they have to add up to equal 180, right? So these 60s match, right? And then if this is 90, this is 60, this is going to have to be what for D? 30. Okay. So my corresponding angles are congruent. That's the first thing I have to check. Okay. The second thing I have to check is, do the corresponding sides match up? Are they proportional? Okay. All right. So you got to make sure you match up the right ones. So if you have your angle measures, like I would choose the side across from the 60 is going to marry up with the side across, 30. The side across from the 30 is going to marry up with the other side across from the 30. So I would do 6 is to 4.5. I would write that as a ratio. Then I would do my 60. Okay, it's across from the 6 radical 3, and this is across from the 4.5 radical 3. So that would be 6 is to 6 radical 3 is to 4.5 radical 3. And then I would look at the 90, 12, and 9. Okay. Now, I've set them up. Now, to see if they're similar, I have to make sure they all divide out to be the same. If there's just 2 sets, I could cross multiply to check. Okay, but if I divided all these out, would they be the same? Okay, the answer is yes. And really, I could cross out those radical 3's because that's like a 1. These are the same fraction, right? So we know those 2 are the same. So I could divide them out. 6 divided by 4.5, that's 1.3 repeating. Okay, this one is going to be 1.3 repeating. What happens if I divide 12 by 9? What's that going to be? 1.3 repeating. Okay, so that tells me that the sides are proportional. So if I know the corresponding angles are congruent and I know that the sides are proportional, does that mean they're similar?
Yes.
Yes. Okay, so then it says write a similarity statement. So the first one, it doesn't matter. If I did what, A, B, C, that'd be fine. Okay, and I'm going to put a little similarity statement. Now, when I wrote A, B, C, I went 30, 60, 90, right? So if I do 30, 60, 90, here, I have to write these 30, 60, 90, okay? So my 30 would be D, my 60 would be E, and my 90 would be F. So that would be D, E, F. Okay? So that's my similarity statement. My corresponding angles are the same, and then we set the sides up to be proportional also. Okay, here's another one. Now, again, I always check my angles, okay? And they're all right. So the corresponding angles are congruent. Now what I want to do is I need to check the corresponding sides, okay? And really there's just 2 of them because they're rectangles. But when I compare, I have to compare length to length, width to width, okay? And so it is big to big. So the biggest side to the biggest side, the smallest side to the smallest side, okay? So if I did length to length, that's 7 to 6, and width to width, are those going to be the same? They're not. I can cross multiply. That gives me 35 and 36. That tells me they're not equal. The other thing I could do is divide it. Okay, 7 divided by 6 is 1.16 repeating. Okay, and 6 divided by 5 is 1.2. The 6 is repeating, not the 1/6. Okay, those aren't the same fraction. Okay, or I could cross multiply. It doesn't matter. You could check it either way. Okay, so the sides are not proportional. Therefore, three dots and make a triangle. That means therefore, the figures are not similar. Okay? Because they have to have congruent angles and proportional sides. Okay? All right. Everybody got that? Okay. Now, we talked about scale factor when we did dilations, right? And we said that it had to be image over pre-image, okay? But in similar figures, who's to say which one was the pre-image and which one was the image, okay? So what you have to do with similar figures is you just have to give the scale factor however they ask for it, in that order, okay? If it doesn't specify, then you can give it however you want to. But if it specifies A, B, C, D to E, F, G, H, that's the order that you have to give it, okay? So, and how do you pick which numbers? Well, you have to pick a pair of numbers that correspond. And so I would pick easy numbers. So like let's say I picked BC, okay, 8. 8 is between the 2 and the 3 arc. So whatever number I marry it with has to be between the 2 and the 3 arc. So what would it go with? 2. So since I want A, B, C, D to E, F, G, H, I take a side from A, B, C, D and the corresponding side from E, F, G, H, and I reduce it. You can write it as a fraction if you want to. Either way, it becomes 4 to 1. Now, let's say I ask for it in the opposite order. Then again, I would take a side from E, F, G, H, which is 2, and a side from A, B, C, D, which is 8. Okay? You could write it as a fraction if you wanted to, and that would be 1/4. If I picked a different pair of sides, would the answer change? Would the scale factor change if I picked a different pair of sides? No, as long as they correspond. So let's say I picked AB, right? What does AB go with? Which one? EH, right? So if I did 16 over 4, I still get 4 to 1, right? That's what makes it similar, is because they have the same scale factor on all the corresponding sides. Okay. Okay, it says that ABCD is similar to RSTUV. We want to find X and Y. Okay, so let's work with X first. Okay, and X is in between R and V. Okay, between R and V. What does it marry up with? Which other number? A and E, right? Okay, so X and 3 go together, all right? So I can do 3 is to X, okay? That's one from here and one from there, okay? Now I need another pair of sides that correspond. BC, okay, BC and ST correspond, okay? So that would be 4 is to 18. So these correspond, 3 is to X and 4 is to 18. So I can set up a proportion and I can figure out X, okay? So I would cross multiply. 18 times 3 is what? 54 equals 4x. Divide both sides by 4. And 54 divided by 4 is 13.5. Okay, now I want to find y. Okay? Y is associated with the TU, right? What does it marry up with? TU marries up with CD, right? Okay, so I could do 5 is to y plus 2, and what would the other side of my proportion look like? Because I went this to that, right? 4 is to 18. I would use the same thing, wouldn't I? Okay, but you got to make sure if you're going left to right, you got to go left to right on both of them. Okay, so 4 is to 18. All right, so we cross multiply, and 18 times 5 is 90. And then we end up with 14y plus 28. Because I have to distribute 14 times y, 14 times 28. Okay? So I got to subtract 28 from 90. And that gives me 62 equals 14y. Divide both sides by 14. And I end up with 4.4. I don't remember that answer. I don't know.
Yeah, I got 20.5.
Oh, you know what? I wrote it down wrong. I was going to say, I do not remember that number. What should I have written? 4. I don't know where I got 14 from. Okay. I made up my own problem, didn't I? I used 14 here and it was 4. Okay, so it was 90 equals, we still have to distribute 4y plus 8. Subtract 8 from both sides, that's what? 82 equals 4y, and then you got what? 20.5? Yeah, that sounds more like the answer. That doesn't sound right. Okay, now, it asked me, what's the scale factor of RSTUV to ABCDE? And since it's saying scale factor and there's similar figures, you have to give it in the order that it asks for. Okay? So you take a side from RSTUV to a side from ABCDE. And you want to use one that they give you if you can, right? We already decided that what goes together? 4 and 18, right? 4 and 18 go together. Which one's going to come first if this is the way they want the scale factor? The 18. So you do 18 over 4, and that reduces to 9 to 2. Okay, so that's my scale factor. Okay. We're almost done. Okay, ABC is similar to XYZ with a scale factor of 2 to 3. Okay, so I have this triangle, A, B, C, and then I have another one that's bigger, and it is X, Y, Z. Now notice when I drew it, since it's A, B, C, I did X, Y, Z, so the corresponding parts were in the right spot. Okay? All right. Now, it says the scale factor is 2 to 3. Now, I can write it as a fraction or as with a colon. Now, I'm going to pick sides. It doesn't say which one's which. It doesn't really matter. This is 6. This is 8. This is 10. Okay? All right. So I'm going to go and I'm going to find, we'll let this be little z because it's across from angle z. We'll let this be little y because it's across from angle y. And we'll let this be little x because it's across from angle x. Okay? And I'm going to use the scale factor and the sides to come up with these lengths. Okay? All right. So my scale factor is 2 to 3. So let's use that scale factor of 2 to 3. Okay? And let's find z first. So I'm going to say, okay, 2 is to 3 as 6 is to what? Okay, well, that might be the answer, but I want to set the proportion up. Okay, you're right, okay, but I want to set the proportion up. Okay, so 2 is to 3 as 6 is to z, okay? All right, as 6 is to z. All right, so then I can do another one. I can do it with the other one. 2 is to 3 as 8 is to what? X. And again, I'm going to use it again. 2 is to 3 as 10 is to y. And so I can solve those proportions. Some of you can just look at it and tell what the answers are. But I can cross multiply, and I get 2z equals 18. So z is 9. Okay, so this right here is 9. Okay, here I get 2x equals 24. So x is 12. And 2y equals 30. And so y is 15. Okay? So if you're given the scale factor in one of the sides, then you can find the other sides if the triangles are similar. Okay, I got one last thing to show you. Yes. Well, one more example and then no problem. Okay, now this is the hardest thing for people to remember. And when I taught this to my advanced classes, this is one thing they forgot about, okay? Now, we said that the sides were proportional in similar triangles, right? Okay? The other thing that's proportional, not only are the sides proportional, but the perimeters are proportional to the scale factor or to the sides. Okay? So basically what that means is that if these are similar, that the perimeter, oops, can't spell perimeter, the perimeter of one is to the perimeter of the other as one side is to the other. Okay? So the perimeter of the red is to the perimeter of the blue as this side is to this side. Okay? So the perimeter to perimeter, side to side. You can set up a proportion like that. Okay? All right. So let's do one. Okay, it says that ABCDE is similar to PQRST. So ABCDE, PQRST. Find the scale factor of ABCDE to PQRST and the perimeter of each polygon. Okay, so if I look at this first one, I need to look at my pictures and then look at what the markings tell me. Okay? If this has a single dash and this has a single dash, what does that mean? They're the same, right? Okay, if this has a double dash, this has a double dash, they're the same, right? So I have all the sides in this one, don't I? What is the perimeter of this guy? Perimeter is when you add up all the sides, right? So 8, 16, 30, okay. Perimeter is 30. All right.
24.
8, 16, 24.
Oh, okay.
I think it's 30. Okay, now we come over here, right? We don't know everything. We know that these are both the same, right? Well, that's all we know. But they're asking me to find the perimeter of both of them, okay? So I'm going to let the perimeter just be x, okay? Now it says find the scale factor. So what's my scale factor going to be? 4 to 3. So AE goes with PT, so it's 4 to 3. So my scale factor is 4 to 3. That's my scale factor. And I can use that scale factor in the perimeters to find the missing perimeter. Okay? So, since it is 4 to 3 like that, I can say, okay, 4 is to 3 as the perimeter of the big one is to the perimeter of the small one. What's the perimeter of the big one? 30. And the perimeter of the small one, we don't know, right? So we're going to let it be x. But this allows us to not have to find all the sides. We can just find the perimeter right off the bat. Okay, so once we get that set up, we cross multiply. We get 4x equals 90. Divide both sides by 4. And that goes in there 22.5. Is that right?
Good job.
Okay, 22.5. All right, so this perimeter is 22.5. Like I said, it keeps us from having to go and find everything, okay? And know that if you have a pair of corresponding sides and the perimeter of one, you can find the perimeter of the other one, okay, without having to find everything, okay? Because they're proportional just like the sides are. All right.